Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, I will be talking about the applications of PCA that we have covered up. Or in general, you can say what are the applications in real time and in what specific domains, dimensionality reduction technique is being used very vastly. So I would talk about few examples here which you can relate as per the real time illustrations. If there is anyone in my audience who is from fintech background or who is from healthcare background, specifically these people will be able to understand pretty well that what I want to convey here. Because see, when we are talking about dimensionality reduction, it is very widely used in almost all the domains, first of all, right? The very first real time application which I think you must have understood so far is in EDA itself, exploratory data analysis. Because if, let's say, I want to analyze the data and if it contains multiple features, multiple dimensions are there, so as a human being I won't be able to analyze higher dimensions of data. I won't be able to understand that what is the internal thing going on if we will be having multiple dimensions. That's the limit, I can say, which we have, right? Limitation that we have. So basically, in that scenario, it's a good idea that if, let's say, you want to analyze any data, you want to do a EDA. So PCA, or I would say dimensional reduction technique, is very widely used there. And even we have seen in our last illustration of PCA that how basically we can utilize the property of eigenvalues, eigenvectors to calculate the PCA1, PCA2, and so on, various components of the principal components analysis, right? Second, very widely used use case would be in the banking domain, where the task is to analyze the risk mitigation factor, right? For example, let's say when we are talking about banking domain, they do have for every customer multiple features, right? Their transactions histories will be there, their CIBIL scores will be there. And let's say they want to analyze that how much risk is there in order to give a loan to any customer, right? So whether the customer is fraud or not. In that case, again, to mitigate that risk part in a banking specific domain, if the features, I would say, are very much high for any customer, for any specific customer, so what they usually prefer is they want to take the relevant information from all the features that they have. So the good idea is to go up with the dimensionality reduction technique and grasp all the important I would say patterns of the features that we have, the values that we have. And what we can do in that scenario is we will apply maybe the PCA. And by saying that, we do have some different techniques as well, in which with the help of that, they will be able to, reduce the dimensions. And then on top of that, they can apply regression or classification problem depending upon what kind of, what type of problem they are solving, whether they are solving a classification problem or they're solving a regression based problem. Third important sector where you will see that this particular dimensional reduction technique is very widely used is again in healthcare. See, when we're talking about healthcare data, we do have multiple features of patients. In that scenario, let's say we had a problem of predicting that whether a patient is diabetic or not. By the way, the same problem I will try to illustrate in the upcoming session where I will do the hands-on. So you will observe that in that case, let's say if we will be having so many features of patients, it would be again impossible for me to analyze the data to understand that what the patient's features are looking like in terms of visualization. Again, in that scenario, I want to convert that into 2D or 3D, and that's a good idea that we will apply PCA in that case as well. Apart from this, you will see in natural language processing, the people who are from that specific domain, we have a technique of word embedding. The major idea of word embedding is to convert the textual data or words to vectors. I'm not sure how many of you are aware, but if you're not, please go refer that. In that case, we have techniques like word to vec, which is basically internally using this PCA technique to reduce the dimensions and giving us the vectors. So you will be able to observe that in almost all the kind of data, whether it is of image-based data where we will be having multiple features, or it be of numeric-based data, or it be of textual data, internally either somehow users are using as a reducing the number of dimensions this technique, or already when we are applying some pre-trained models, or already we are fetching some models from sklearn, so you will observe internally somehow this dimensional reduction technique is going on. So if you will see the internal working of the algorithms, you will be able to analyze that. For example, just now I have given you an example of word to vec, where you will be able to observe that this particular I would say PCA is working. Similarly, in the images per se, if let's say you want to compress the image, right? Or maybe you want to do the face recognition, you are doing a project of recognizing the face. In that case, again, there will be multiple features. In that case, again, we want to reduce the number of dimensions of those features by taking the important values, important parameters, which will basically help my model to recognize the face. Nowadays, though, we do have, I think everyone does have a smartphone, where maximum number of times in almost all the companies, they have made a face recognition tool in their smartphones itself. So that feature is again using the image based data, right? And internally, if you will be able to observe, so that the computation will be faster, automatically my model will be able to recognize the face. Internally, again, this PCA and any other technique with respect to the dimensional reduction is working on. So all these are the real-time applications of PCA. And now I hope you would be easily able to understand that why it is important in order to, learn. Because at any point of time, whenever you feel that we do have multiple features and we want to reduce this number of features, definitely you have to go with this technique, because this technique is basically helping us to take the important information as well. Also, we are reducing the number of dimensions as well. That's the beauty behind this techniques, right? So with this, let's end today's session. I will come up with another session where now we will start jumping towards the hands-on application of this PCA, where our focus is on the implementation per se. Although in the previous session, if you will be able to observe, I have talked about from scratch how PCA works. So in the upcoming session, my major focus is on to show you that how with the help of sklearn, you can, do the implementation of PCA. So without wasting any time, let's try to understand in the upcoming part of the video that how the implementation will be done via sklearn. Bye-bye everyone. I'll see you all in the upcoming session.